Hello, everyone. Good morning. How are you? The weather is beautiful, so I feel very happy. And today we do the last section for this semester. By the way, this is page 66. Section 5.6. Multiple Wiener Ito integral. In 1951, K. Ito introduced the multiple Wiener integral. He called this multiple Wiener integral, but nowadays we call this multiple Wiener Ito integral. That is the integral from A to B, the integral from A to B of a function f in L2 of the space, the interval from A to B to the power n. And so it's f of t sub 1, t sub 2, to t sub n. And then db t1, db t2, all the way to db tn. I don't give you the exact definition of this here, but I will tell you what it is in the case when n equal to 2 in a second. For the definition of the multiple Wiener Ito integral, please see my book. My book for detail. It is the introduction to stochastic integration. By Springer and published in 2006. Now, there is a link between the multiple Wiener Ito integral and our new theory of stochastic integration. To motivate this link, or we can call it a relationship. Let us consider the case n equal to 2. Namely, it is the double Wiener-Ito integral. Okay, I turn to the next page. Okay, so this is page 67. So this is part A. Ito's definition. Of the double Wiener-Ito integral. So that f x y be a continuous function on the square AB square. So here we have a situation like this. This is A, this is A. This is B, this is B. And so we have this. This is S, this is T. And we divide this interval from A to B into partition. So this is the diagonal line. And here we have also T sub I minus 1. And this is T sub I. Ito's definition of the double integral from A to B, of f s t dbs dbt equals to the limit as mesh, the partition goes to 0, and this is a summation. F, you see the partition for S and for partition for T is the same. And so here this is F at the point T sub I minus 1. And T is the same T sub Z minus 1. And then the Brownian motion increment for S is T sub I, delta B, T sub Z. But this summation is over Z different from I different from Z. This is the most critical point in the multiple Wiener Ito integral. This is the definition. The motivation of this is a little bit complicated, but essentially it is to remove the part in the diagonal line, to remove those part here. Those little square along the diagonal line, remove them, and this is it's called renormalization. For the detail, please see my book. So in particular, that f, x, and gx be continuous function. In L2 from A to B. Then this double into AB, f of S, g of t, dbs, ebt is the limit of the summation I different from j. If I is different from j, is from here. And then we have for f of t sub I minus 1, and then g of t sub j minus 1. This fg is from replacing f by f and g. Okay, and then of course we have a Brownian motion increment. And this is the limit. Now this sum is over here, but now we can do this. This sum over all ij from 1 to n, blah, 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 blah. And then minus summation when I equal to j. I equal to j is I from 1 to n, and then this will be t f g, and you see j is the same as I. So this is, so here, this and this are the same. And then the first sum, when we sum this over, maybe I'll go to the next page in order to explain this clearly. Okay, page 68. Okay, the first sum is the limit. And the first sum over ij. We can sum this over I, and then jj. So the first summation is the same thing as here. Summation I from 1 to n of f t sub I minus 1 times summation j from 1 to n of g t sub I minus 1 and then delta b t sub j. And then minus the second term here is summation I from 1 to n f of t sub I minus 1, and this is the same thing, g of t sub I minus 1. And then we have a Brownian motion increment since I equal to j, so this is square here. And now you see, this is very easy to see. This summation as n goes to infinity, or the mesh of delta goes to 0, it goes to the Wiener integral from a to b of ft dbt. This is the Wiener integral because the integrand is it determines the function in L2. And then after that, with the sum, the second sum over j goes to the integral from a to b of gt dbt. And then the second term, this as n goes to infinity, note that this is delta almost equal to delta t sub it is delta t sub I. And so the second summation goes to the integral from a to b of ft gt dt. Namely, we have the equality. This double integral from a to b of f s g t dbs dbt equals to the integral from a to b of f s dbs. This is a Wiener integral, and the second one is also a Wiener integral. Minus the integral from a to b, f t gt dt. Note that we don't have the separation of the integral because of the actual term this. So therefore you see that the double Wiener integral of fs and gt is given by this equality. This is double Wiener Ito integral. And these two are Wiener integral. Okay, so this is for this video. We'll go to the next one.